Okay, this video is to just quickly go over the um, our Lagrange points, and I also want to talk a little bit about the Kirkwood gap example in the text. So this first bit I have here, if you remember in the previous video when I was solving for the first three Lagrange points, I came up with quintic equations and I had to solve them numerically. I thought it'd be worthwhile just to show how that's done in Mathematica. And that's done by a function called find root. So here you go ahead and put in everything that you got. And I'm working in units of little r here. I set it arbitrarily equal to 1. But you go ahead, you put in your function, you tell it what you're solving for, and you give it an initial guess. And often it doesn't even have to be a very good guess. If you go ahead and run it without the working precision option, it will tell you that it wasn't terribly happy. It's still not super happy when we increase the working precision. This error basically is just telling me that these numbers are to fewer significant figures than the answer that I'm asking for, to 10 figures. That's really all it's complaining about. So we know we're physicists, we know how to deal with that, and we only trust the first few digits of the answer. So anyway, here's L1, L2, and L3 found that way. Okay, now I want to go in briefly on the Kirkwood gaps here. So if you make a plot of the number of asteroids that you find in different as a function of the distance from the sun, you get something like this. And what I want you to notice here is that, say like right here at just a shade over 2.5 AUs out, there is nothing. There are absolutely no asteroids at that distance. And you can see also here at about 2.8 and a quarter, a little about 2.96. There's some, but it's greatly reduced, and so forth. What we've drawn in here is we've noted the ratio of the basically we're noting here that the asteroid would orbit the sun 3 times to Jupiter's 1 time. And that's the clue there, is Jupiter's constant tugs on the asteroid are what make it go away. So I'm following the example on this in your text. You can find the startup of this on page 297. And I set it up here to look at that 3-to-1 resonance. So I went ahead and plotted it out for, say, 10 years. And you can see if I put a satellite there, or if I put an asteroid there, it gets wheeled out pretty quickly. And if I make it go longer, you can see it just keeps heading out, out, out from the solar system. And I took it to ridiculous extremes out here. So you can see the combined tugs of Jupiter work to throw out any asteroids that try to set up house in that orbit. It goes ahead and tosses them out. I very much encourage you to work through this example for yourself. You'll find it on page 297 of the text. Okay.